Hello, in this video we are going to study about the fifth experiment of our system software and compiler design lab, that is simulation of deterministic finite automaton. Already we have studied about the finite automata. So it is basically called as recognizes. It can either say yes or no for any input string that we give to the automata. Basically, finite automata comes in two flavors. The first one is non-deterministic finite automata. In short, we can call it as NFA. And the next one is deterministic finite automata. In short, we can call it as DFA. The difference between non-deterministic and deterministic finite automata is that in non-deterministic, um, there is no restrictions on the labels of their edges. That is, when we have a state, we can there is no restriction on the input symbols. We can have more than one edge for a single input symbol, and also we have the privilege of having a empty string or epsilon which can move to another state. But in deterministic finite automata, it is restricted that for each state and for each symbol, we can have exactly one edge, and we cannot have epsilon transition also. So these are the differences between the deterministic and the non-deterministic finite automata. So uh, the definition of this deterministic finite automata is that it is defined as five tuples, having five tuples, q, sigma, delta, q naught, and f. Q represents the finite set of states, and sigma represents the set of input symbols, which we can call it as the alphabet. And so the alphabet can be any set of symbols that we can take. And the transition function, it is represented using the delta. So this gives us the state to which it moves from one state on reading an particular input symbol. So from any state on reading an input symbol to which state it moves. So that is given by the transition function. And for every deterministic finite automata, we have an initial, or we can call it as a start state. Then we also have a set of accept states, or we can also even call it as the final states. So the final state can be more than one. So as we have seen the difference between deterministic and non-deterministic, so this deterministic finite automaton is a special case of NFA where we don't have any moves on input. This is epsilon. Okay, we don't have input on epsilon symbol, and for every state and for every input symbol A, there is exactly one edge coming out of every state. So there cannot be more than one edge for the same input symbol from a single state. So now the purpose of this lab is we have to simulate the deterministic finite automata. We want to give the input for the any deterministic finite automata, and we have to give the input string and check whether it is accepted by the DFA or not. So we can take any regular language and we can formulate a transition table similar to this. So you can take any regular language, and you can draw a transition graph or a transition table, which includes the states as well as the what are all the input symbols you're going to use. And here in this case, let us take an example where this is A is the start state or the initial state, and D is the final state. And we have a set of transitions given here for this DFA. And the to simulate a DFA, what is the input required is this transition table. So first you need to identify a regular language and draw either a transition graph or a transition table. And you need to know the number of states that we are going to use in the given for the given DFA, and what are all the input symbols. So the basically the input should be, you need to get the number of states, what is the number of states that you are going to use, and what are all the states. So these are all the inputs we need to get from the user, and what is the input symbols that you are going to use, and then very importantly this transition functions. So for each input state on each input symbol, what is the transition that is going to happen. So this transition table we are going to get as input from the user. So from input state A, on reading symbol A, what is the state? What is the transition? So this input has to be received from the user. So you need to get the number of states and what are all the states and what are all the input symbols, and then the based on this states and the input symbols, what is the transition. So this thing has to be got as input, and after getting this input, we are also going to get an input string. So for example, here for this transition table, I have taken the input string as AABB. So now we want to check whether this string is accepted by the given DFA or not. So here the final state is D. So if this input string ends up in the state D, then we can say that the string is accepted by the DFA. So here we have an algorithm to do that. Uh, the first initially we get so the start state is considered as yes not. So here in our case, the start state is A, and the accepting state here is D. So if you check this algorithm, so initially we assign this initial state to the state yes, and then we start reading the input symbol one by one. So, so initially now we have the state as A, and then we read the character from the given input string. So this input string has to be read till the end of file comes. So till the last character is read, we have to keep reading the input string. So now by using this function nextchar, we are reading the character from the given input string, and the given input string is now A. So, so till this character becomes end of file, we are going to repeat this steps. So since C is not equal to end of file, the first thing what we are going to do is we are going to see what is the transition. So this move of S comma C, this function it is going to give what is the transition on that particular state and input. So now currently this state is A and the input symbol is small a. So what is the transition of A comma A? So the transition of A on A is B. So now the current state is equal to B, and then we can read the next input character by using this function. So now the input character will be again small a. So now still the character C has not become the end of file. So again we check the transition on these two symbols. What is B on A? So B on A is capital B again. So again the character, the state is B, and the next character that we are going to read is small b. So now C will be B. So again C is not equal to end of file. So again we check the transition of these two symbols. So B on B is capital C. So in the next step the state becomes C, and then we again read the next character. So the next character is B. So again this does not becomes the end of file. So again check what is C on B. It is capital D. Okay, so now the state becomes capital D, and when you check there is no more input symbol, that is it reads the end of file character. So now it comes out of the loop. Since C is equal to end of the file, it comes out of the loop, and check whether yes is in the final state. So already we have this D is in the set of final states. So now it returns the output as yes. And if suppose the last symbol of your given input ends up in some other state, then which is not in the final state list, then it will return the no. So this is the algorithm for simulating the deterministic finite automata. The input initially you have to get the number of states. So you can take any regular language or any regular expression and construct a transition table and identify what are all the input states and what are all the input symbols. So get that as input from the user. Get the number of states and get the states and the input symbols and then the transition functions. So all these has to be got as input from the user, and then you need to mention which is the accepting state and which is the final state. Then using this algorithm, take any input string, you can take any input string for that transition table and check whether it is accepted by the machine or not. Thank you.